Greetings learners. Last time this is what I asked you to do. This is what you are asked to derive. You are asked to derive from the first principle. Look at that. And then you have got to find the gradient where x is equals to 1. Now let's see how this is done. Here we go. We've got f at x, which is x squared minus x there. As you can see, this is a parabola. So we are looking to find the gradient at a point for a parabola. This is our f at x, and then f at x plus h. Remember, f at x plus h, it means where there is x in an original equation, we are putting x plus h. As you can see, x plus h, it is worked out, and then it is minus there, and then x plus h. So we need to multiply in, as you can see there. And then this is our formula for the first principle. You copy it as it is. Remember to copy this down until you substitute your h as 0. Now it is substituted there. This is our x plus h there. It is substituted. And then look at f at x. This is our f at x there. Remember, there is a minus outside. I did not put brackets today because we are getting used to this now. So it will be minus outside, and then sorry, there is a mistake here. No, it's correct. So here we've got a minus outside, and then a plus inside because of a minus. And then remember here, the additive inverses. This is an additive inverse of this one. Again, this is an additive inverse of this one. And then what you're left with after dealing with the additive inverses must contain h, as we have said. And then after this, you factorize, you take out h. Even if you can see that the common factor maybe is 2x. Do not worry about the 2, just take out h. The purpose of factorizing is to get rid of h as a denominator there, okay? So even if you can see that the common factor is not just h, there is something else, maybe 2h squared, just take out h. The purpose is to get rid of this, okay? Is to get rid of h as a denominator. Now after taking out the common factor of h, this is what you'll be left with, and then you substitute there, and that is your answer there. Right, let's take a look at this one now. It says here, determine from the first principle the derivative of. Now take a look at this. We have dealt with a straight line, we have dealt with a parabola. Now this one is a hyperbola. This is an equation of a hyperbola. Okay, remember the hyperbola is also a curve. So if it is a curve, then it means it has got a gradient at a point. Okay, so this is what we are looking at. Okay, now we've got f at x, our f at x, which is 1 over x, and then we need our f at x plus h, so it will be 1 over x plus h. Now don't try to sort this out to take this to a numerator. Don't try to do it, just leave it as it is. Okay, now we need to copy our formula as it is, and then we substitute. Right, so that is our formula there, and then the next thing is to substitute. Okay, right, we have substituted there. As you can see, remember we've got our limit as h tends to 0. This is our f at x plus h minus f at x all over h. Now we need to work this out. These are fractions, okay? Now working with the fractions, you know that you must find the LCD. So in this case, it will be x times this, okay? Right, this is our LCD. This, remember, everything is all over h. It's a fraction over a fraction. So it is this is our LCD. Okay, now let us work it out. all this divided by this will divide, we'll be left with this, and this multiplied by that, you'll be left with x there. Coming to this side, this divided by this will divide, you'll be left with this, but then there is a minus there. Okay, so we'll be having minus x minus h. Okay, now let us write down what is being left there. Remember this, these are additive inverses. Okay, now let them deal with them, and then you'll be left with limit sh tends to 0. Right, this is what you'll be left with. Now as you can see, this is a fraction, but then it has a denominator. Now let us write this the way we understand it. Okay, as you can see, it is this divided by this, so this is divided by h. These are fractions. What do you do when you're dividing with fractions? You change this to a multiplication sign, and then you look for a reciprocal there. Okay, now let's do that. Right, let us change this to a multiplication sign. It is multiplied by reciprocal there. Remember, this is over 1, so this will be 1 over h. Okay, and then these will divide. Okay, they will divide, and then what will you be left with is, remember, limit sh tends to 0. This is what you'll be left with, and then now you are substituting. It is minus 1 over x into x plus, you put 0 there. As you can see, this will be 1 over, sorry, it will be minus 1 over x squared, and that will be the derivative. Now this is what I want you to try. You've got to derive from the first principle. It is f at x equals to minus 3 over x, and then f at x equals to x cubed. Okay, thank you.